Andrei. Hello to Maxima Insights, and I'm happy to have you here.
Hello everyone, I am QA lead at Maxima with over 13 years of experience in IT field. My daily job is related to looking into quality assurance, making sure that requirements are met properly and business is satisfied.
Awesome. So, Andrei, as we talked before, executing post-release validation directly in the production environment, it's high stakes. Like, you usually don't push things straight to production. So how do you build the necessary client trust and accountability to perform testing at that level?
This is basically the very critical question because stepping into production environment is a high stakes scenario which we face during enterprise software delivery. Over time, we have hardly built the client trust by consistent reliability, which gave us a bit of ultimate direct access to the production environment for our post-release validation testing activities, some other operation activities, and gaining that level of trust didn't happen overnight. As we all know that we need to work quite long under some part of a relationship between clients and yourself. And it came to us through consistently demonstrating that our testing activities are safe, controlled, reliable, and the most important, not destructive. So it doesn't impact the real production system by our testing. The turning point for us was establishing proactive risk resolution. Before that level of strict post-release validation and data isolation, we were completely focused on anticipating and neutralizing all potential gaps and issues which might occur or which that could ever reach the live production. So basically we were finding all issues, gaps on the stage of integration testing, which was the last one before production.
Right.
But this focus-driven approach proved to our clients that we can safely validate changes on production live ecosystem without risking the live operations.
Awesome.
And our approach focused on creating safe environment without risking clients' user data.
That's cool. Yeah, I think that's important for every client basically. Like, you don't want to expose the users to any issues because one big fuck up and everything just goes down and you're all over the news. Everybody knows what's happening.
And here today I would like to share some techniques or some approach which we use to get that level of accountability. And first of all, we mainly rely on data isolation through feature flags, some kind of sandbox routing. So when we execute validation checks, we have predefined test data, so without touching the real production. And also we have specific attributes such as test mode true in request payload. So that attribute acts as a toggle for our outbound process. And once integration middleware process that payload which has that attribute test mode true, means that this is test payload. So it means it shouldn't harm the real production. It basically that flag says to the system route that transaction to to safe, controlled sandbox environment or third-party gateway. It ensures that no real customer data is corrupted, maybe impacted or depleted accidentally by our tests, as well as no live operations are triggered in overall. And second thing, which is also we prioritize end-to-end traceability. So by utilizing observability, as we know all, trust requires visibility. Everyone wants to see something, some dashboards, some graphics, flowcharts, or as a statistic, how it's supposed to do, or how it doesn't supposed to do, to check the metadata, whether it goes to the right way. And by utilizing these observability tools, as well as traceability tracking systems, let's say, we prove to our actually we not approve, we show to our clients, stakeholders, that how our test data routed and where it flows. And in our architecture, every message is traced, starting from the landing the message into our system through inbound process, also operating through our system with various different actions. It moves to outbound, which sends to some third-party applications. And all that process basically stored as historical records under logs, dashboards. We have created variety of task jobs which alert us in case of some failure. And it shows to clients what exactly is testing data, and it's tagged to some particular operations and what is live operations. So we can simply differentiate and look through the observability tools what is going on with requests. Not only just plain of different requests, it shows the properly what is testing request and what is the production request.
Yeah, and the clients, they have a source of truth basically that
Yes.
they can refer to, so they don't have to rely on what someone says, but they can actually go in, look what's in the system, see it with their own eyes, and actually trust you, because they know that I don't know, you're not talking stuff that is made up, but you have actually something to back up everything you say and everything that you do. So that's awesome.
Yes, thank you. And the final thing about it, we also adapted quite good. Finally, we proved that our actions are fully reversible. It means when operation action is done, we can easily, it can be easy pass the system without touching the production, as well as we can safely undone the operation if accidentally it goes into wrong direction. And it gives kind of complete protection to the production actions, as well as we have in terms of facing some test request, we'll face some error. It simply doesn't impact the production ecosystem. And ultimately, gaining that level of trust allowed us to transition from purely non-productional testing to having the autonomy to validate hotfixes, releases on production environment with confidence. and those releases utilizing that approach have been highly successful so far, providing the required level of assurance, and which means that our post releases are controlled, secured, and isolated from the productional data, productional actions, and operations.
Got it. Andrei, high pressure deployments, high pressure deployment cutovers with strict deadlines, they often lead to human error or just mistakes along the way. So, how do you structure cutover schedules and testing flows to minimize this risk?
Regarding cutovers, those periods of time, even when the very strong teams are struggle because of closed deadlines, high pressure, which leads to human errors, because we are all human beings and sometimes something might happen. And in our project, I am personally prefer to use three-pillar strategy, where I use first, it's a kind of preparation approach. Second, we have peer reviews, and third is validation after the changes done for cutover. And as we know that cutovers, let's step back to get better clarification what is cutover terminology. It's you can think about release. It's kind of release, but it implies to the processes when the old legacy part of the system or entire system are turned off, and newly created or maybe some third-party application are used and enabled on the production. So basically switching from one to another. And in majority cases, it requires just some configuration changes. No major updates under the application, which we have usually for it doesn't require the major updates for the features or application. It just have some configuration changes. And let's dive into the first point which I mentioned about preparation. So we have the people who are going to work. We should assign the proper person to the task which is going to be done during the cutover. It should contain also the timestamp as well as some other predefined criteria, and it always nice to have some playbook how it's supposed to be done. Next, just after the preparation done, we move to the peer review process when people are looking into configuration changes that are supposed to be deployed in the particular cutover. And not only QA is required to do that peer review, we also involve developers and DevOps to see whether we have the proper changes designed. And after implementation of those changes in production, we move to the phase of validation, and deriving from the first question, where during the post-release validation we use the same techniques of data isolation and using observability tools to make it done. And in case validation passes, we simply send a report about successful cutover. For the situation that our tests are not passed, or situations for some cancellations from the client side. It might be some different situations, postponing the release, cutover. Postponing the cutover, we might have the situation to revert all changes. And we have during the preparation phase, we have configuration change as well as revert scripts.
So, in essence, everything comes back to good preparation and making sure that you prepare very, very well for what's to come, because you know that it will come eventually. And yeah, the planning, the strategy, like that's where you have to actually put in the most work to later not run in circles and scream because there is a fire.
Yes, so good preparation is number one key for the cutovers, as well as prioritize work which not to be done within one day. Pressure is one of disadvantages of cutovers, which is sometimes very huge.
Yeah. So coming to the last question, so when organizations are undergoing massive infrastructure changes, how do you design automated regression testing to make sure that the existing integrations and setups don't break?
Okay. Going to the automation and preparation, when we are going through the massive infrastructure changes, we always afraid that something might go wrong and we might break the existing automated scripts. So I prefer to have technique of smart automation testing of regression suits, where we find the core functionality for test purposes, and where we exclude all hard-coded configurations required to run tests. We prefer to automate those features which can be safely isolated from the entire infrastructure. Those can be API tests, which is quite useful in terms of regression to make sure that functionality is working properly. Finally, I deploy test cases, automated test cases into pipeline runs. It gives a continuous integration testing approach. It provides continuous integration approach for testing the overall entire application during the infrastructure changing process, because it will not happen overnight. It might sometimes require some part of changes for infrastructure, and next time we have other part of infrastructure changes. And it is a very nice technique to have to execute test cases on daily basis to make sure that we are not breaking the system over the time of infrastructure changes.
Yeah, like everything spread across a period of time, so you have to adapt to that.
Yes, and it's good to use environment agnostic approach when we are not rely on environment itself. I mean, what I mentioned before on configuration settings. We should overthink before we do automation changes or automation creation, or during creating automated tests. We should overthink about the possibility of massive infrastructure changes later on.
Awesome.
To be prepared for that one.
So, Andrei, thank you very much for today.
Thank you, Filisin. It was very nice to
Yeah.
talk.